Okay, so we've created and edited standard ACLs, and we've talked about some of the drawbacks of standard ACLs, at least if we're using them to filter and control traffic. So let's take a look at creating an extended ACL. Now, the difference between standard and extended: standard will filter only on source IP address. Extended will filter on source IP address, destination IP address, and source and destination port number. So here's what I want to do. I want to make it so that this PC can hit the web browser here. Nobody else should have any other access to this server, including on any other port, including this one. So this should only, it shouldn't be able to ping it, it shouldn't be able to FTP to it, it shouldn't be able to do anything except web browsing on port 80. But everybody should have full access to this PC or anything else on the network. The only thing I want to block is access to here. Nobody should have access to here on any port except for this device, which should have access on port 80. Now again, visualize traffic. So all of this traffic from this entire network is going to be coming in here, out here. So in G00, out or out G02. This traffic will be coming in G01, out G02. Now, one other thing to think about here, and that is general rule of thumb, is that you should put an extended access control list as close as possible to the source of the traffic. So in that, if we're to follow that, it means that we should, to filter this traffic coming through here, we should put it inbound on G01. Remember when we did standard access controls in the previous video? We did it outbound on G02 because standard should typically go as close as possible to the source or to the destination of the traffic, extended as close as possible to the source. Now that is a general rule of thumb, and I'm going to follow it this time, even though as we do this, you'll realize it would actually make more sense to go ahead and put the extended access control list here because we're going to be filtering traffic from both interfaces. But we're going to go ahead and follow Cisco's best practice for the moment. In real life, I probably wouldn't. It depends on your circumstances. But we're going to do it just for demonstration purposes. So let's open up our router. And we're going to create this as a named extended access control list. And remember, one of the benefits of named access control lists is that it gives us a descriptor in the name. It also gives us a better way to edit. We talked about that in a previous video. So I'm going to create a new access controller. So it's IP access, I'll go ahead and spell it out, access list extended, and I'm going to call it HTTP underscore access. Now, doing it in all caps is not necessary. That is a convention that a lot of people will follow just because it makes it stand out when you're looking at the config. All right, remember things processed from top down. So the first line I want to be is this. It's permit, and then we're going to question mark our way through this because I want to show you the options. So let's start out right here at the beginning. We have a sequence number that we can set. We can tell it to permit, deny, or remark. And a remark basically just adds a comment, and that can be really useful sometimes. Now, I don't care about sequence number, so I'm not going to do that. I'm not going to set a remark. I'm just going to permit my first traffic. So it's permit, and then we can specify a protocol. And it can get pretty specific here. So I want to permit. Now, this is where we go back to what we learned before. If I'm going to allow web traffic runs on TCP port 80. So my protocol is going to be TCP. And then I need to set my source. So I can use a source address, the keyword any, or the keyword host. So I want to do a specific host. Now, if I was doing a network, then I'd type in the source address and the wildcard mask. But I'm just doing a specific host. So permit host, and then the host's IP address, 192.168.1.11. Then I'm going to set the destination. And again, I can use the address followed by the wildcard mask, the keyword any. I can use EQ. I can do a specific port number. GT is greater than specific port numbers. LT is less. You see this can get fairly extreme. Um, so I want to permit TCP from the host 192.168.1.2.11 to the host, and our server is 192.168.3.5. And because I used host keyword on both of those, I don't have to set the wildcard mask. Then, so this gives me my source and destination address. Then I can specify things on port 80. So equals, and then when you do a question mark here, it's going to show you where you can put in a port number, or you can specify specific keywords. Now, I tend to use port numbers instead of keywords. Doesn't really matter. Cisco tends to translate by port numbers to keywords. So, depending on your version of your iOS, if you allow port 80, it may come up when you do a show run and say equal www. All right, so I'm permitting TCP from this host to that host, specifically on port 80. Now I want to block all other traffic to that host. So that's going to be deny IP from, and I can do IP, I can do TCP, I can do UDP, I can do ICMP. I want to block all of it. So I'm going to deny IP from anything to host 192.168.3.5. And I don't have to specify a port number here because I want to block all of it. So that's going to block everything. But I do want to allow all other traffic. So that's where I would need a permit statement. Permit IP from any to any, and that allows all other traffic. All right. So hopefully you can see how we put this together. Now, key thing here, and the standard access controllers video, I said always visualize traffic flow. Same thing holds here, true here. The other thing is use your question mark, because until you get really, really comfortable writing these things, having that little prompt that says, hey, this is what comes next is really, really useful. All right, let's find out if this thing works. Now, I'm going to exit out of here, back to my global config mode. Now, I want to block traffic coming this way and coming this way. Both of those are going to converge right here. So honestly, that would be the best place to put it again, port G02 outbound, and it will work. However, the standard practice is put it as close as possible to the source of the traffic. Now, in real life, I would put it here, honestly, given this circumstance. But just to illustrate best practices, I'm going to go ahead and put it where the best practices say to put it. So I'm going to do interface G00 IP access group HTTP underscore access in. And then, because that's going to filter any traffic coming here, I also want to filter traffic coming here. Now you'll notice I'm only permitting from here, so I could write a completely separate access list here if I wanted to, that just says block access here, permit everything else. But I'm going to go ahead and reapply the same one that I already have. And we'll talk about reasons for that here in just a second. So let me go into interface G01 and do IP access group HTTP access in. All right, so why did I do it that way? Well, the reason I did is because later on, if I want to add, let's say I add another PC down here, and I want this PC to have access there, then all I have to do is edit that access list and add that other PC in, and we're good. And I'm maintaining one access list instead of two. There is one drawback to this approach, also to naming it HTTP access. And that is you can apply one access list per interface, per direction, per protocol. So I can have on interface G01 right here, I can have an IPv6 access list in and IPv6 access list out, an IPv4 access in and IPv4 access out. That's it. So I wouldn't want to make an IP access list for HTTP access, and then another one for DNS access, and then another one for email access, and then another one for, Samba access or SMB access. I wouldn't want to do all of that. I couldn't do all of that. I'd have to create one, and that one has to filter everything. Okay, let's see if it works. So I'm going to start with this PC. And I'm going to go to my command prompt. There we go. And let's just extend this out a little bit. And I am going to ping 192.168.3.5. And I get a reply back saying destination host unreachable. So let me ping 192.168.3.10. And that is our other workstation over there. So ARPA's going to fail, and then we get communication. Okay, that works. Can I access the web server? So I'm going to open up my browser, and I'm going to browse to 192.168.3.5. Well, apparently no matter how many times I tell it to go, it's not going to go, which means you go away. Which means it works exactly the way we want it to. Let's go to this PC. And again, we'll spread this out a little bit. We'll go to our command prompt. We'll ping 192.168.3.5, and our ping fails, so we can't ping our web server. Can we ping our PC at 3.10? Yes. Now here's the real proof. Can we web browse to 3.5? So open up our web browser, 192.168.3.5, and there we go. It works perfectly. All right, now, just to make sure that it's not a fluke, one of the things I always encourage you to do is go after you've tested the ACL, and always, always, always test your ACLs. Test both what should be blocked and what shouldn't be blocked. Once you've tested everything, and then go back and show IP access lists and make sure that you are getting matches. And this right here says this line has been used 6 times. This line has been used 87 times to deny access to that PC. This one has been used 8 times to allow access to everything else. All right, so it looks like our access list lines are being used, which they should be because we've tested every single one of them. And that's how you test and verify an access list. Always, always, always double check your access lists. Test what should work, test what shouldn't work, and then go back in and do the show access list and make sure that it is getting matches and that traffic is actually being filtered by your access control list. I've had instances where I tested an access control list and it looked like it didn't work. I went in, looked at the access control list, it said it wasn't getting any matches. Come to find out it was a routing problem somewhere else. So it looked like it was working even though it wasn't. So always make sure that they work correctly. Okay, so there is our creating and verifying an extended ACL.